All right, so the problem that you have here, you're taking copper 1 sulfide, and it's being heated in the presence of oxygen gas, which is O2, and we're producing solid copper 1 oxide and sulfur dioxide gas. In order to start off the problem, you first need to come up with a balanced chemical equation here. Copper is positive 1, sulfide has a negative 2 charge, so when you charge this out and you do switch, drop, and reduce, we're going to get 2 coppers and 1 sulfur, and it's heated in the presence of oxygen gas, which we know is O2. And we're told that we make a copper 1 oxide, so copper has a positive 1 charge here, oxygen has a negative 2, so it's Cu2O, and we're also making a sulfur dioxide gas. And if you take a look here, we do have some hints for the phases, but I'm just gonna, oh, I'm sorry, I didn't realize that none of that was showing up. But we're not gonna record the subscripts here for the phases because we're just doing stoichiometry here. And we're being asked how many kilograms of oxygen are required. So my oxygen here, this is going to be your B. It's what we're trying to figure out. And keep in mind the units, they're not asking for grams, but they want kilograms of the oxygen. Okay. And we are beginning with 2.8 kilograms of copper 1 oxide. This is my A here. And again, keep in mind the units. You're starting off with kilograms here. So we know that basically we're going to be using the in switch out method to go from 2.8 kilograms of copper 1 oxide out to kilograms of oxygen gas. And let's go ahead and begin. So we have 2.8 kilograms, and I'm going to just go ahead and change this over into grams because we know that we're going to use grams in the molar mass. So 2.8 kilograms, we're going to times that by 1,000 and get that it's 2,800 grams of copper oxide. Okay, so if you guys look back at your stoichiometry roadmap, we know that in order to start off with grams, we need to convert it out into moles. And for the copper, we have 63.546. We have 2 of them. Each oxygen is 16. So I end up with the molar mass of 143.092 grams in 1 mole of copper oxide. Okay. And getting to this part, we know that we're going to be doing a multimole switch. So on the bottom, I have moles of copper oxide, and we're switching this to moles of oxygen. Okay. But keep in mind here, when I wrote out my chemical equation, I forgot to balance it. And in order to use the multimole ratio, we have to have a balanced chemical equation. So let's check to see what we need to do here for the balancing. I have 2 coppers here, 2 there. I have 1 sulfur, 1 sulfur. The part where you're going to get a little stuck is the oxygens. I have 2 here, and I have 1 and 2 here. So I have a total of 3. So we could easily fix this by taking the one that is odd and just doubling that up. So we get 2 now. That gives me 4 coppers. I'm going to put a 2 right there. And we have 2 sulfurs. And now my total count of oxygen, I have 4 here and I have 2 there, so it's a total of 6. And I know that I could balance this out by putting a 3 right there. Okay, so now we could go ahead and get the information that we need here. I have 3 moles of oxygen gas, and I have 2 moles of copper oxide. Okay, and I'm trying to get this out into grams. So we have 1 mole of O2, and I know that's equal to 32 grams of oxygen. And we also are going to convert this out to kilograms for the final step. So I know that there's 1,000 grams in 1 kilogram. And if you multiply and divide, you should get to our answer here. So 2,800 times that by 3 times 32. I got 268,800. And then I'm going to divide by 143.092 times 2 times 1,000. And it looks like we started off with 2 significant figures in our problem, so I'm going to round my answer to 2 significant figures. And we end up with 0.94 kilograms of oxygen gas. And that's it.